Yeah. So now somehow yeah, okay. So let's go through the most important things to confirm that we got the understanding about what is IoT and what are the main concepts. That's what we learned yesterday. First of all, we went through the definition and main terms. And main terms, abbreviation to remember is, of course, IoT, Internet of Things, Industrial Internet of Things, Web of Things, Machine to Machine, Artificial Intelligence of Things, Internet of Everything, Cyber Physical Systems. Those are the acronyms that you will meet everywhere, reading or working with IoT. The main definitions are understanding what IoT is and what is not. That's for what those definitions are. So one perspective is component based, like. So IoT is the network of physical objects, which called things. And they have embedded sensors, there is software and other technologies. They can connect and they can exchange the data with other devices and the other systems over the internet. So the crucial in this definition is what we repeat all the time through the whole course is physical. So it must be physical device. Collecting data, exchange the data, and connection over the internet protocols. So more generic view and general scientific definition is presented by Mkhale recently. So the most is a global infrastructure that integrates physical objects into virtual world. I would say that this is, for me, even more favorite. Of course, it doesn't say that it uses internet, but we assume when we talk about virtual world, we assume that all virtual things are happening in the internet one or another way. So IoT is the only technology concept, I don't know what it could be else, maybe concept in broader way, that integrates the physical objects to our virtual systems. Then we went through the main concepts of IoT. Main concepts include sensors, devices, communication protocols, network technologies of networking, cloud computing, different services that works with the data, transform the data, store the data, do whatever, and different data analytics applications and tools. So you already see from this description that it has very hierarchical structure. So the data is always collected from devices, by devices from the sensors, from the real world. And then it goes like hierarchically through different types of networking, sending data to different networks and receiving them commands through different networks. And then it goes to some cloud or to real server, to some computing place. And then basically the end goal is to make some analytics reaction, the response. Then we have gone through some of the concepts yesterday. We also discussed almost in each module or in each topic, we try to take the marine role there, because that's important for this course, why we need to know about IoT in the maritime. So we somehow discussed that sensors they exist always in as long as the machines and motors and engines exist, almost since that some kind of way how to measure vibration, temperature, and other parameters exist. But these sensors that exist before and on the ships or on factory, on any other place, they were not networked. They were mostly monitored locally on some local control panels, and they used very often manual logging or basic automation. I have been in several ships. In early times, there was some kind of logging journals that there was all parameters written by hands. And even I'm so old that I remember even that. So, and of course, there was lack of remote diagnostics or cloud connectivity. That's kind of obvious things what IoT changes. So there were always way to monitor and to do something, but this was very localized, very local, and very simplistic, half manual way to do that. And IoT give us a lot of new possibilities how to extend this, to how to integrate the physical devices through the internet, and how to put users and decision makers more close to the engine, to the device. We also went through what kind of implications had like IoT on some real use cases. So there are different areas, different solutions, and different tasks that always were in scope of maritime. For example, asset tracking in the big harbor areas. It used to be almost like manual, and it could be, of course, with some GPS delayed updates later on, but basically there was no real-time GPS tracking. And with IoT introduction, it became possible to track ships, vehicles, containers in almost real time. And it obviously has positive impact in terms that it's increased visibility, reduced losses, and of course, it's positive turn in many cases. IoT, not only positive things. I mean, there are not really disadvantages, but there are a lot of problems because it's not very mature technology. And also we have changing legislation, regulations that IoT also faces more than other technologies, such things like privacies. I know a lot of very educated software developers and highly educated people who almost hate IoT because they believe that this is the way how people can be controlled and followed and so on. So, I mean, these kind of things, they always exist. We also understand that IoT make big breakthrough in the maintenance services. So it used to be, before the era of IoT, time-based on reactive maintenance. You know what does it mean? When something broken, it's broken. Then you go to fix, or then you have schedule for regular maintenance. IoT gave possibility to develop predictive maintenance. So it's purely result of wide IoT industrial implementations, how it's become possible to combine real historical data from certain system and the current condition monitoring data from how it performs. And then by combining, you can make some AI analytics or something that helps you to say that, okay, two similar looking systems in two similar ships can break in different times. Then port and docking operations, they are affected a lot by IoT. There are smart port, and we talk today a little bit more about smart port concept. And so the smart port concept integrates different kind of systems that automates and give it could be like some whales control or some logistic movements, but harbor port is port. There are a lot of services that can be automated. Then fleet control, this is number one IoT solution growing around the world. So it's the most popular topic together with the healthcare fleet control. It's a very kind of hot topic in IoT business now. Fuel route optimization, it gets better and better. I have a case about that, which used to be 10 years ago about. So there were small companies that were trying to sell industrial services to big shipyards. Those services was retrofitting of old ships, but everybody can retrofit old ships. But this company had some special services. Depends on what you want. It can add you additional sensors, which previously was not on the old ship. It can add for example, for the electricity consumption monitoring, water, for the route optimization, for the fuel, for everything. So depends on so it's fully customized service. And then the small company offers that for, let's say, if you add, if you fix the ship, and if you buy additionally, like for about 100,000 euros, so you get all this nice sensors and solutions for optimization of whatever you want to optimize. Nobody wanted to buy, because they said, okay, if you go to make retrofitting in the big shipyard, they probably do almost the same, but almost free, because it's like in the bigger package included or something. So nobody wanted to buy from the small company this as a service, like as a separate service of retrofitting, including updated, better, like IoT enabled services. So what they did, they said, okay, you only pay for the sensors or for the hardware and for our installation hour. And then we share with you risks. So you pay us half of the price of our investment. And if nothing happened, then you paid only half of and we lost like maybe altogether the cost was like 50,000. They said, okay, you pay 25,000. We pay 25,000, and then this is our risk, is it happened or not. So this was better, so-called value-based pricing. This was better offer, and some companies agreed on that. But finally, the small company said that, but if we deliver what we promise, saving of fuels 30%, saving of electricity that much percent. If we deliver what we promised in 5 years, in 1 year, there was a schedule in which year they promise to gain some savings. Then we want 1% of that. So that was the interesting case, because in case of one quite big ship, they finally, instead of paying 100,000 for like lump sum, they paid almost million to the small company, because they achieved what they promised. So they saved on fuel. I don't remember exactly what was the saving on fuel, probably route optimization, something else. And the 1% of that was very big ship. So I don't remember exact the numbers, but it was at least 10 times more they paid than they would have paid as a lump sum, which was good for small company and good for big also, because they achieved those savings. So even changing of the business model only become possible because of implementing of IoT. Then there is also such things like crew safety environment and for example, looking for tracing for the passengers, how they are moving, and what is the crowd-based analysis of in the big ships. So a lot of opportunities there. I will tell later about interesting case. Maybe you have some good ideas how to implement it, because so far we are looking in some research project, we are looking for some ideas, but nobody came up with the good idea. We talked a little bit more about that. Yeah, there also you can read yourself later from the materials. There is of course real solution and solution providers already exist. Those are like big systems for pleasure crafts, for fleet monitoring, for the container shipping logistics. So those are already existing solutions, and so it means that basically there are a lot of examples of IoT solutions in maritime, and this is a bit phenomena that we know, and Professor Cesare and the research group has made some research regarding to the required knowledge about the technologies in maritime, and IoT was listed as one of the needed. So like there is a need and there is a gap what we try to fill now with the knowledge in IoT, but there are already a lot of solutions developed and deployed to the maritime. So it's kind of here and there. So like there are a lot of companies that already have it and deploy and enjoy that, and on the other side, there are still in academia maybe a little bit delay in the delivering this knowledge. And actually, I talked with the shipyards. They also think that they feel the same, that they have lack of the knowledge. So maybe we can do something with that. We discussed yesterday, if you would be in charge to create IoT solution, what you should do. So there is nothing too super artificial how to do that. You do that probably the same way how you do that with other systems. So you define the problem. For example, your problem is that you want to detect mission faults, and all of them or more than you have now or something. Then you create the architecture. And this is important that I would like to remind from yesterday, that when you create architecture, no matter is IoT-based AI or any other architecture, you first need to clearly have what it is now. So you only can make a change and create a budget estimations and create a transition if you know where you are now, and then you define where you want to be. And it's usually not possible with IoT to make the big step. So you have several intermediate milestone: proof of concept, first pilot, first prototype, first MVP, then first production, and then in the production you have to scale after that. So like you have production version on one vessel, but you need to for 10, and it can be completely different technology if you have everything for one working in IoT. If you have something for one, you cannot say that it works for 10. Just a second. I have to say that there is a noise. There is something going on around the boat. Okay. Just a second. Sorry for that. Hello. There is some noise I cannot hear. Okay, let's continue. Then also important thing is not only to create architecture, of course, then you need to have the things, what kind of data you collect, how to process and analyze the data, and so on. But you also need to secure the system. Today we talk a bit more about different kind of attacks that nowadays is happening in the maritime. So what kind of weak system, what kind of weak places, and what types of attack recently has been made on maritime ship IoT systems. Then you need to build user interfaces for people. It should be a human-centric approach to make them. But basically, there is nothing like unusual except that IoT usually require for this, as I said, more iterations and more. I don't know any IoT system that has been created based on the design. It's not possible because physical world will add you all there. If you remember, the main definition of IoT is presence of physical devices and physical parameters. And you can plan whatever, but presence of physical environment will can completely change your ideas, your architectures. Um, I can tell one interesting story. I think I didn't tell that before. If you remember, yesterday showed you the tags that are RFID passive tags that was can be glued or used for whatever to trace assets, but then there are some readers that should read it. For example, manual readers, and then we had a project which is I cannot say your names because it's for military, but it was some, let's call it assets of military that we labeled with this tag that when there is it's very important in military that those assets that they are on place because this kind of assets, they have to be always monitored in army. So the solution owner and solution who is provider, they were from UK. So I was, because I'm a Finnish citizen, I was only accepted to the place, to army, and they were not accepted, like they are foreigners. So I had to learn all these things and make installation in this army military base. So it was pilot, but the tags was exactly what I showed yesterday. And those tags, this UK guy, he's instructed me because I was not the author of the solution. I was just the kind of engineer who installed that and test and deploy. And he was saying that, okay, you need to use this glue to fix them to the assets. And I was saying that, well, I have some doubts about this glue that they will stay there, but I say just people, it's not any secret for everybody. Sometimes people from UK, they are very kind of self-confident too much, and he was saying just do what I told you to do. This is the things what you should do. You just should glue them, and they will stay. I know that. Okay, I mean, I glue them to hundreds of assets, and then after first military training, half of them were lost. And then when I told it, and then they used the, the scanners, this handheld, to find in the far northern part of Finland to find them. They found all these tags, but that was not the purpose. The purpose was to find the assets, not the tags. But I told him that, half of them were lost. Well, why? I said, because it's -30. And with -30, your glue doesn't work. And this reaction I was very wondered how it can be possible outside -30. So, I mean, yes, it is possible every winter here. So, and we then put it to different glue that was tolerating our frost, and it was okay. But that's what I'm trying to say, that it's a physical world. It's not only human stupidity, but it really can be really tough conditions or unusual conditions. So sometimes it could be even so hot that some glue melt or something like that. So you need to have prototypes. That's the main message of the developing architecture IoT solutions. Same for the ships. You cannot do that like buy 10,000 tags, install them, and voila. You need to make the test and pilots and really trial for the IoT. That's the main difference between maybe something that can be more planned or maybe even with the shipbuilding that very sequential. So IoT is not sequential. So we also check how it usually would be done in the large cruise ship. For example, with the example that you need to make the focus and measure the passenger comfort, safety, and for that you need different kind of AC, air conditioning system, humidity, temperature, passenger presence, and which kind of sensors you can use for that. And you need to plan, you need to think how they connect. That's a very important topic. How do they connect to the system? What kind of data you can process locally? What kind of data you have to send on shore? So this is also important. How big space those sensors takes, and they connect, especially the connections to the sensors, or from the sensors to the gateways, so how it is in the ship. Then we also, of course, you need to design cloud analytics and what you want to know with this data. How do you send the data to the digital twin to ensure that it's covered very well? And then, of course, what do you do if something wrong? What's your decision-making point? I have here, I need to tell one story. Maybe you would get some ideas, and maybe this project is on hold. It's in Lappeenranta, together with Lappeenranta University, Meyer, Turku, and some other companies, Finnish company. We started to develop project, and we still need IoT company who would be, or actually any company who would make the shipbuilding service during the some service, that data-driven service during that would help somehow innovate process of shipbuilding or process of ship operation. We had some idea how to do different services, but I can just challenge you with the question. Maybe you can think about that. Maybe you can send me something, or we can discuss if we have time. In the big ships, and not only on the big ships, but any ships when there are a lot of people, you know that there are some alarm systems. If something require immediately, if it's severe situation and it required that people would immediately leave from the ship or evacuated from the ship or something, how to know that, for example, in cruise ship or in some other ship, how to know that there are nobody left in the cabins? I understood that it only can be checked manually, like somebody need to walk, or sometimes maybe there is not even time for that to walk and check. There could be all kind of sensors, but all of them are not really fully answering responding to the problem. For example, this opening, closing the door doesn't say that there is inside somebody. Of course, you can try to calculate, but it doesn't say. All kind of thermal sensors that has temperature, they are messed up with the computers and possibly other electronic devices that makes heat inside. If somebody leave the computer devices inside, so you don't really know, is there somebody alive, or is it from some electronics that heat comes? Cameras are not possible because of privacy. You cannot have camera. So there are different, we were thinking about the wearables, that you can have some wearable, and this wearable can somehow say that are you inside, to register to the for example, indoor reader inside the cabin reader or something like that. But yeah, if you know some better, or if you know some more reliable, because I mean, if you are not 100% sure, you probably cannot leave the ship if you are not 100% sure that there are some people. I'm not sure exactly about the procedure, but it's something that you safety and responsibility. So at least one project we're still kind of looking for this kind of case. And we discussed why, again, why naval architects and maritime engineers need to know about IoT. And we came to the conclusion that it's because of the design, location, size, communication sensors might take. You need to know how to plan, to build, how to make design. It's because of life cycle thinking. So you need to somehow, when you think, enable data-driven ship and data-driven lifecycle management for the ships. For the integration with the digital twins, the naval architects are the best who know about all needed systems, places that needs to send information to digital twins. So I believe that the best digital twins should be directly designed by the naval architects. I mean the content, because digital twin is what? Digital twin is the content and context and the object. So there are three things. So you duplicate some physical device, you describe the context in which this device is, and you describe the properties. So basically that's it. So you only kind of people who created the ship knows where are the places that has to be continuously monitored and checked and how often and what kind of data and what to do. And of course, yeah, safety classification is coming almost mandatory nowadays to know about that and to take care about IoT and to follow to have some knowledge on that. We also discussed about the architecture. So architecture of IoT has 4 layers: sensing layer, network layer, data processing layer, and application layer. This is something to remember. So there are 4 layers. Each layer has its own functions and components, and each layer employs their own rules, which calls protocols. And each layer has connections to other layers, and each layer has some kind of communications between inside the layer, so between the layers and inside the layer with the component. So briefly, we went through the physical layer. We had example of RFID, for example, RFID and soil sensor. So what kind of data can be connected, or what kind of data can be collected, and what are the physical layers? Basically, physical layers are sensors and devices. So sensors, actuators, embedded systems, microcontrollers, edge devices, gateway, everything is on the lower level is physical layer. Then network topology is the layer on the networking layer. We went through what does it mean, network layer? It means how devices connected to the cloud between themselves, how do they send data, how the network is built. And we discussed that in IoT there are 3 types of connectivities and network topology. It's a star when each device connects to the central hub separately. The mesh, when they can connect through each other, they are capable for transferring the data nodes, which are also sensors, and all kind of hybrids. Then we discussed, this is very important things. I want to remind you also that there are different types of communication models in IoT. And they are some of them classical communication, like request response. You ask something, you get response. Some of them also like push pull. You push data somewhere and you pull from somebody data. But there are also more typical for IoT communication layer types, like publish subscribe. You publish to somewhere whatever data. Many clients publish to the same broker, and there are many consumers are using from the same broker. It also looks like a bit centralized, but there is no single broker. You can have many brokers. And then broker also can communicate. So, I mean, it's not that centric like request response, for example. And exclusive pair, when you pair exclusively two devices, that's also common. Then we continue to discuss the different layers, and there are important layer, middleware platforms. It's middleware layer. It's the cloud computing layer. So this layer it's kind of, they are more or less already standardized services that helps you to connect, to route data, to send, to store, to process, to do something with the data, to make from the raw data something meaningful. And there are already standardized services and even some standards like, for example, I worked with this Fivare. So this is a very big, very expensive EU project that tried to standardize data from different sensors, different types, different systems in IoT. So it works mainly in smart cities, but it's also trying to spread for other domains as well. So because there are huge amount of sensors and sensor providers, and they use messaging protocols could be the same, but except messaging protocols, there's a lot of other things, what you need to main kind of program, make a code if those devices are not really from different providers. So for that, they try to create on the middleware some standards that, okay, your device, your system, not device even, but your service should be FIWAR compatible or some I don't know, some other standard. So the whole idea to bring standardization not only on the messaging or protocol level, but on the service level, that you would be really just low coding. You don't need to code anything to connect to applications or to services together. And there are already a lot of platform providers for the middleware platform that we will work with Azure IoT Hub. And the application layer is the highest. You collect data not for fun. You want to do something with that. So you want to make some analytics. You want to make some actions. You want to apply machine learning and AI methods to find some patterns and reactions. So no, this is kind of understandable what do we need to do, but it's actually a very big problem. Because first people learn how to collect data from IoT, but then very few companies knew how to use them properly. Because no, I mean that when you want to monitor engine, it's clear what you want to know. Or when you want to monitor the bending of your structure, it's clear what you want to know. But additionally to that, you collect huge amount of data from the sensors, and most of them were not used properly. So you can collect data about anything using IoT, but how to use it, how to create profitable use case and profitable service from that's the problem, and it's still problem. So basically what we learned yesterday is the main IoT concepts: sensors, devices, communication protocols, networking technologies, cloud computing platforms. And we learned that it's visible that the architecture of IoT solution is layered. You need to know the sensors, you need to define the topology for the network, how you connect them, and you need to figure out which cloud platform you use and what kind of services you use for data processing and data transformation. And you need to define and create applications what do you want to do with this data. So this was hopefully it become today a little bit more clear. It's a summary of yesterday. And then we step into the difficult part, is the different protocols and overview. First of all, I would like to ask you, at this point, do you have any questions right now? If you don't have questions, let's continue. So yesterday we started to discuss about protocol. It's so kind of already getting to be technical things that the reasonable question, why do we need to know about that? And we had yesterday, if you remember, some review, why do you need to know? I hope it was like convincing, why do you need to know about that? Because you need to know because of many, many things. And one reason, if you want to understand that, so some devices or some devices, they can use different protocols for different purposes. They have several connectivities between themselves, with the sensors and with the network and gateways. When you design the system, you need to figure out which one to use, especially if it can use several. In many cases, you can choose I don't say that it's for all devices and sensors, but for many. That's why you need to really understand what do you want and how to choose them. And for that, you need to more or less know what's available. Basically, it's not that clear like it's written here, but main protocols that are used in IoT can be categorized as protocols that are communicating with the devices. So it's basically between the device and the gateway. If you see, they are not internet protocols, except if your device doesn't have, it might be so that your device itself, your sensor doesn't have internet protocol. It needs gateway. So like if you use some like LoRa or Zigbee device capable, it cannot directly connect to the internet. It needs some gateway. So your device communicate with LoRa device, with the LoRa gateway. And LoRa gateway is capable to transform the data from the LoRa format to the format that can be introduced to the internet and sent over internet. And so it's kind of translation gateways, let's say. Azure also have translation gateway. There are a lot of proprietary protocols between sensors and the edge, for example, device. So that's what this communication could be. Different protocols. Those LoRa has been invented 2012 explicitly for the IoT. The Bluetooth used before, but it also or very often for wearables used in IoT. Zigbee, also the IoT protocol. Then there is transport. Transport, basically, it's internet protocols that are used to send the data further to the internet. If it's a big network behind the internet gateway, it also can use proprietary transport protocol for like inside like in LoRa network. Then there are messaging protocols that are more or less standard for IoT. This is how your message will look like, and they are working over in all IoT devices. We stopped yesterday in MQTT. It's the centric is the most important, I would say, protocol in IoT. So let me remind you that protocol is, first of all, you of course know that, but just to repeat that it's the set of rules. And set of rules, how do you format the data? What is the size? How you define what do you do with data? For example, if your protocol is transport, you need to send to define where do you send it, where do you push it, or from where you get it, so it's the set of rules. And MQTT protocol uses publish subscribe model, which we discussed earlier, and you will use in the hands-on MQTT messaging. So it means that it knows that you know the broker who will receive your message. You send the message to the broker, and you send, and hardly you receive anything from that. Sometimes you can make a quality of service such that you might receive something that the broker receive, but you can also just send, and you can, of course, if it required, you can repeat if the message, if during some seconds broker said that, well, I should have received from you something, but I didn't, but it's already some kind of more complicated way to communicate it. Mostly to simplify that, you send something and then you listen broker as a customer, you see that, okay, there is something interesting because I'm interested in such topic. It's like a titles in newspaper. You read some, you looking for some titles and you read the titles. This is the typical structure of MQTT message. And the structure is so that first, as I said, it's a telemetry topic for device. So topic can have many topic is that what you send or from where you read. So it's kind of your point of interest, what you are interested. So there's usually device ID or ship or vehicle or some other or message or event. So you can build your topic based on your interest. Then there is so it's kind of what from where or to where you publish or read. Then the actual content called payload, and payload has JSON structure, so payload can have fields and the content. So you can figure out what, and so if I send temperature, it will say temperature colon 100. And then some other things like what type of content you send. So it's a technical things. It's like admin things for the message itself. Why it's important? Because it's simple. You can read it with different tools. You can transform that, and this is more or less standard payload. So as you can see, it's not any pictures, or you cannot send pictures or streaming of from camera or anything using MQTT. You have to send really something small and meaningful. So your devices that are sending low payload messages, they are using MQTT. If you need from camera to send some video, you need to use HTTP, for example, like browser, same protocol. I haven't used this protocol, constraint application protocol, but I know that it's used in maritime. It's even more, I guess, simple. And if the transport protocol is it's not TCP/IP, which is MQTT require, but it's UDP. So it runs over UDP. So it can be made in even lower power devices and very kind of lossy network. So this UDP doesn't guarantee anything that you deliver there. You received what you deliver. So, but it's usually like, for example, it's used for the tracking of the containers. It's sent from time to time, very rarely, and it's or here it says that maritime use cases removed this valve control on the ballast system. So is it open or closed? So this kind of very small message, very rarely. Fuel sensor level also use co-op messaging because there is nothing like no real time needed, no critical. Loss of the packages and data doesn't really change too much. So I mean, not so important. So it says that I have read some discussions about that. So why co-op is ideal in maritime IoT, because it works well over noisy and satellite networks. So because it's a small, you need to save money when you use satellite networks. And yeah, there are some other advantages. The structure is quite simple also, how you use it. No, HTTPS, you all know, you're using it every day, many times in a day. Basically, it's the hypertext transfer protocol, and it has, in contrast to MQTT, it uses request response model, if you remember what we talked about. So you request something, you get page back. And the same here. So if you need high payload or high security, this is the best in IoT. It's used for the security critical or for interoperability in many, for example, if you send something from your systems to the corporate in intranet or something, if you need to send some information, you have to use HTTP, because even if it would be small messages and would be go as MQTT, but MQTT ports are always closed, often closed for the corporate security. MQTT need different ports, so they are closed. So you cannot use MQTT and you cannot send. So you have to use it either as HTTP or as a MQTT over WebSocket. So it's anyway web. But this is also quite simple structure of the message. So you request, you post something, then you know where to send and you know what to, in payload is very simple. So the MQP is also important protocol. It's like MQTT. It's a IoT specific protocol for messaging, but it's more sophisticated. It's more complex. It has more capabilities. It's more reliable. You can configure it so that you know for sure is your message arrived, has your message arrived or not, and you can get responses. You can also make multiplexing. For example, if you have 100 devices, you can use one connection, AMQP, one connection to the hub. You don't need to open 100 connections to the hub, to the broker. You can multiplex connection to the one channel. So there are a lot of things that you can do differently, but it's also more heavy and then MQTT. And it's usually used when you have two enterprise systems. For example, ship as a system, enterprise system, and the harbor, and they have their own mobile network or something. Then you use MQP broker to communicate between those two systems. So if you need to, and as I said, some of the devices, many, they can use any of this protocol, or other way around. Your system, your hub, your middleware platform, able to connect devices that supports 3 protocols, not more. So, for example, Azure IoT Hub, which is the heart of the Microsoft IoT solution, it only supports 3 protocols to connect: MQTT, AMQP, and HTTP. So if you want to connect any device, and you have seen how many different devices and protocols exist, there are like list of the technologies, also at least 10 or 15 which we went through, but this middleware platform understand only 3. So what you need to do, you need either to configure your device to use one of the 3 protocols, or you have to put in between of your device and cloud hub, you need to put gateway, translation gateway that would translate your LoRa protocol, your Zigbee, your Bluetooth communication to the one of the 3, which is supported by the hub. So it sounds a bit simplistic, but it's in a nutshell, it is like that. So I have tried to clarify a little bit with AMQP, because it's more and more used, and it's used in such complex systems as ships and in maritime quite often. So why do you want to prefer AMQP compared to any other protocols? So you can figure out, so if you need some kind of high reliability of the transaction, for example, you have some mission critical or financial application that you cannot lose, you use AMQP. If you have some kind of complex communications, like you need to find one place to reach the message, that one broker, then another, then send to some other device back something. So it's kind of complex routing of the data. You prefer to use MQTT. Then if you need high security and already built on roles on the protocol level, that you kind of authentication, who can send, which device can send, which cannot, so then you use AMQP. Yeah, so there are clear rules which one you configure and select when you build the solution. There are also widely used protocol DDS. I never have used that in anywhere, but it's common for the maritime. So what I learned about that it's it's very low latency protocol. It's almost possible to provide real-time communication. For example, with MQTT, you have to make some tricks, or you have to make something to make it really real time. If you send your data to broker and you subscribe to read broker, so you depends on the broker. So it's almost real time, but you cannot say that it's like 100% immediate response, because you don't know what happens in the broker. Broker has the queues, priorities, and so on. So you need to make some tricks with MQTT, because when it comes to the MQTT to the broker, you need to there is different priorities how you access the messages. So some messages has higher priorities, some clients has higher priorities, and so on. So, but usually you don't rely on MQTT as a protocol, usually with the high priority, unless it goes directly to the cloud. With data distributed service, I read that this is the real-time communication, so you can rely on that. And it could use as a peer-to-peer, so you don't need any central broker in between. You just send it from system to the system. In cruise ships, control system used to share engine status and GPS between different modules inside the ships. If some modules need to know if inside the ship, then they use this protocol too. So it doesn't go outside, it goes inside. But very quickly, because it's real time. So I would like to learn more about this, but don't have yet any kind of case. There are also some comparison, as we just discussed, how and what kind of protocols you are using and what for. For example, as we just mentioned, the DDS is the decentralized. It can be peer-to-peer. You don't need any central broker. You can from system to the system. It's real-time, and it's used for robotics because of that reason, for critical systems, because it's real-time. You immediately can arrange some response on the message what you received. High setup, high. So in MQTT, it's always centralized through the broker or hub. It's not really real-time, or very nearly real-time, and it's used for sending telemetry. So what I just showed you, this kind of normal parameters from the engines, from the environment, from this. I understood that DDS is more like used not for the big telemetry data, but for some kind of informants, some events. This is important topic, and this is coming now. What? Because I know from some shipyards that they very quickly now setting up cybersecurity teams. There were always cybersecurity people who were competent, and they were using shipyards earlier. They were using the kind of external services to check because there is one computer, there will be attack, and there are hundreds of computers on the ship. There will be, and communications and protocols, so there will be a lot of attacks, and there is. But the things, it's visible now, because in very, very big shipyard, there are 2 or 3 persons that are responsible for cybersecurity risks. And now it's obviously not enough, and it suddenly start to come. I don't know what does it kind of why, but maybe because of digitalization, very, very now coming fastly to the maritime, maybe because of digital twins, maybe because there is something to steal, like a data of passengers or something. But now they start to, earlier it worked so that, okay, they hired external service companies to make this different kind of test, penetration test, different kind of tests for the cyber systems. Now they try to increase internally education and knowledge inside the shipyard about cybersecurity threats. I'm working in one project that is very concerned about that, and we are making different kind of games and simulation to teach specialists internally shipyards what kind of is that to teach them that this is a risk what you are doing. So this is one of the things. They are very simple. Sometimes, like, you walk in the shipyard, you walk nearby the ship and you see the cable. This is risk, and big risk. Or you see a router that has been used, a gateway that has been used to get the network temporarily to test some module. No, you need network. You don't have always Wi-Fi inside the ship when you are building that. So you use some temporary network to get, and then you just forget that there. And this is a risk, big risk, because you have access to the system open, which you're not supposed to have, and you don't know what is this Chinese device can do more than give you network. So I mean, that's all kind of risks. But how do you? There is a clear procedure. What should you do on the protocol level, at least in IoT, to avoid and to straighten your security? And for example, you need to use those special protocols that are like, you need to use this TLS SSL for MQTT, and HTTP means that you need to have how encrypted traffic. And then authentication. This is very common. We will see with you on hands-on that you can access the cloud from your IoT device using different kind of modes. For example, using some almost passwords or key parts or something. But this is not the way how it should be. You always should have, if you have external connections from device to the hub, if you have external wireless connection to the service, you need to use certificates, and they should be validated. They should be properly issued and managed. So changed if they're compromised or if they're getting old and so on. And this is not very easy. This is a big, it requires big system that are running in your also as part of your digital system. You need to have certificate management system. So different kind of tokens, keys, and others. So then is this like also you need to manage signatures and certificates. Then you need to have access for your safety. You need to have access control. There must be implemented role-based access, because people and systems are some system. It's not only people-based access. So I can do. You will be authorized. You are already authorized to my tenant for the hands-on as a contributor, so you can do a lot there. That's why I ask you not to do much, because not to create some resources or something. But in the real world, in operations and shipbuilding, you don't need always full access to all resources. So you need to design to which resources who needs to have which kind of access. And it's not only about people. Some other systems also connect to your system. So those systems are also, in a sense, objects that also some software need access to this hub only as a reader, some only as a writer, or as a reader and writer. So I mean, that's all should be designed. And it goes like role-based access for people and for the systems. And of course, you need to have physical security for your devices. You have to think what's happened if they are stolen, if they are replaced, if they are somehow otherwise compromised. So there are security methods that are used on different levels of the protocols. For example, as we mentioned already, you need to use encryption on the transport level, but on the network level, sometimes you need to use VPN. For example, in the for military ships and for military base, they are not allowing to go data going through the internet. So if they use VPNs, they use all kind of firewalls and other things. So you need to configure so that your data wouldn't travel through the internet, though it goes to the cloud. So you have to have your own cloud, or you have to have isolated networks or private networks. So there are a lot of methods how to do that. And security for device itself, we mentioned already, but even device itself can say something. Do you remember yesterday I showed you tracker, which is, it can say if it's, for example, taken or shaked too much or taken away. So it can send some alarm. So that's also some kind of security. All kind of security we already have. We have attackers that can intercept or alters the data. We have kind of have this DOS attack when there are huge amount of data sent and they are trying to affect the performance of your devices. So they will send so much that you will get down or something. And the data leakage, they can steal the data. If there is a place if there is data leakage, they can steal it. So there was in cruise ships, there was like a case when they stolen the passenger personal data about where they are and about something else. So it's always, always possible. And again, what you do what you can. You design the system that it would be secure. You use the security available methods. Your architecture should be, all modules of the system should be as possible, all components isolated as much as possible. And classification societies give recommendations about your digital systems, how different systems of, for example, control these automation systems, LNG systems, digital part, then digital this management, and then some other systems that bridge, they have to be like isolated from each other and how they connect to each other. So there are some recommendations on that already written by classification society. Yes. So this way we finished the module about the protocols and about security of the protocols and about the most common protocols that used in IoT. Do you have any questions so far? Okay.
Maybe I have a very short one, and probably you already told something about, but just to recap, there is a matter of cost in all of them, in a sense. Some is expensive, some other are cheaper. Is any difference, is strong difference, or any protocol is okay? One is cheaper, one is expensive, but it's not order of magnitude.
Yeah, we will come to this in this module because by itself, protocol is just set of rules. It doesn't cost anything, but what cost is connectivity. So of course, there are different prices for different types of connectivity. And of course, connectivities are using different protocols, but it's kind of, let's put it like that, that protocols are only rules, but different types of connectivity implies different costs. From the very cheap to like airfeed, what I showed you, there is nothing in the connectivity costs for that, it's free, to the satellites that are getting cheaper, but they are the most expensive. And cellular, basically, all cellular are the most expensive. It's understandable. Some of the signals go through the satellites, some are kept prices by the greedy operators of mobile networks. But yes, there are differences on connectivity. And when you choose the protocol and communications, you think about that very much. Yes, sure. Yeah. And of course, I have comparison later, other additionally to the price, what other things needs to be considered. So now we are going to welcome to IoT devices and connectivities. This is very crucial for the novel architect. First of all, because we discussed that already many times, you need to think about how you connect to the place where you need to connect. So from the sensor to like devices to the intermediate gateways or central hubs or shore management control centers in the harbors. More or less, those connectivities, they can change and they have to change. If you need urgently to send some satellite information in the middle of ocean, it's expensive, but it's usually little payload, small. But when you come to the harbor, it would be nice to change your cellular connection to the Wi-Fi, which is usually cheaper and almost like much cheaper. So all these things and your systems should tolerate this switch automatically like any other system. So you need to seamlessly go from all this kind of, or basically how to say, if several available, your system should choose is it cheapest, fastest, or the most capable what you need to choose. So there are always choice. So but let's start with the basic things. If you remember, we have layered architecture for the IoT system, and the lowest layer is sensor. And sensor and IoT device, those are different things. But first, very easy, what we can sense nowadays, and we already went through yesterday, so we can sense, measure from the environment temperature, humidity, on temperature on any environment, on air, water, other liquids, soil, whatever, temperature of machines. Then humidity, proximity, how far, distance, presence. Motion sensors are very developed, light sensors that you can use. I have, like for example, for anything, for flowers, it's very useful. Gas and other volatile particles in air. That's for methane, CO, and for other biological things and non-biological like particles. You can do. It's actually on the big ships, maybe also important. I don't know is there or not nowadays, but many people nowadays have allergy, especially on the mold. It's like, and there must be a lot of mold, or at least in the moisture conditions, like in the sea and ocean, there is a risk to have a mold when there is textile. So you can use nowadays some sensors that improve the quality of the passenger satisfaction if you somehow can prevent the mold by monitoring continuously what kind of level of possible mold. It's not that easy. I heard that there are not too good sensors, but there are some ways of figuring out how comfortable air for the passengers, let's say, or for the workers somewhere in machine department. You can measure vibration, which is very important for structures, and sound sensors, pressure sensors. Then, once again, sensor is not IoT device. Sensor is just sensing. IoT device is a bigger physical things. IoT device includes the sensors, but it's not a sensor. IoT device also must include the way how to send data. So it should have communication module. It could be IoT device, not necessarily directly can send to internet, not at all. It can send to its own network, for example, mesh network, or for example, LoRa network, or for example, Zigbee, but it needs to be able to communicate, to send data further. And then to be an IoT, finally, this further means that it should arrive to internet gateway. And then absolutely majority of the device has some kind of software or configuration that allows them to, first of all, configure where does it send device, and second, make some kind of preliminary, sometimes very, very good data processing. Some devices might have AI elements that they read from the raw data, like every millisecond they can read something. And then they process that and they send once in a second, or even more rarely, meaningful, clever, processed value. I was making the software for the very simple for the scale for the big trucks. They are in the place when they collect the stones. There are huge trucks that in Finland there is this, like you have in Italy, this marmari. So we have this, I don't know English word, some other stone, and gray granite. So there are those mines when they break them. So the scales are under the road, and the the scale is very simple. It's just serial data coming from the scale, so serial data. So we have made some kind of small mini computer device, which was between the simple serial device, that's serial data, and between the cloud. So, and this was actually IoT device. So it gets data to the serial port just like every 10 times, it's configurable 10 times per second. And it could be any kind of garbage, because scale, they're outside. And there's wind, car is big. The wind makes kind of sailing effect for the car because it's big. And then also car is not like standing like dead. It's also a little bit, there are motors, some vibration. And so the scales are very sensitive. They can send plus minus 20 kilos, plus minus 40 kilos. Then drivers can like move their jump or whatever. So we can say that in this case, scale is sensor. It's just sensing whatever weight it can sense. But then they are connected with the wires to this computer, and this computer is IoT device. This computer gets all this garbage and process that, put it in the array, analyze that during several seconds. Then, okay, now it's stabilized, it's not moving. I can see the patterns. That okay, now is the most of the measurements within this range. That okay, now I know the correct weight. And then when it's know the correct weight, it sent it to the cloud. So instead of hundreds of the measurements from serial port from this device, it sent only one meaningful, which actually real weight of the car that will be charged because they are paid by how much those stones what is the weight of the stone. So this is a very simple, well, it wasn't very simple to make it, but a classical example of what is device, what is not. So device should have connectivity and can process some data, or it's not necessarily, but it can collect data, maybe processed, and mandatory to send it further. Here you can see the device which is collecting the data from soil and from air, humidity, temperature, and soil moisture. Device, so sensors are sensing, and we just went through which kind of sensors it's possible to make. So devices are different. So devices can be just sensing devices that collects data from environment or from the machines. They can be actuators. Those actuators, they can perform physical actions. They can do something. They can close fan, can switch on, switch off. They can switch on the fan, switch off the fan. They can close or open valve. They can do some physical things. So usually they need some motor for that. So or some kind of mechanical things to do that. Then there are controllers that can make decision and coordinate between different sensors. So actuator switches open, switches close, something like that. Wearables, we all have wearables. So it's one on the body, some watch, some rings, some whatever. Then home automation devices. You also know already about that a lot. Industrial IoT devices, they could be rugged devices, and like what I told you, this was some kind of rugged computer that could walk outside. And then healthcare IoT devices, automotive, agricultural, maritime. I yesterday read about maritime structured sensors. I never have seen that. It would be nice to see that. Like device has several connections for 8 sensors. So you can add 7 sensors to one IoT device, and each sensor is like almost welded. I'm not sure is it true or not welded to the structure in the critical places that you can, those sensors are there always, and they are sensing the bending of the structure. So so in that sense, the sensor itself, which is welded into the structure, it's not device, it's a sensor. Device is something that receives the data from the sensor and then process it and send it further to the gateway. There are also edge devices. We need to talk separately on that tomorrow, maybe. Edge devices are important. They're big industrial machines, fast. They can be, edge could be inside your ship, or edge could be even virtual in the cloud, but edge usually has 2 functions. Either it's translate the proprietor protocols from the sensors to something that can be sent over internet to the hub, or it just for connectivity. So it doesn't translate anything because device behind already use the proper protocol, but device cannot send for some reason. For example, in the ships, edge are used, almost all intelligent processing of the data are made on the edge inside the ship. There is only very small and important are sent over satellite to the shore, or when you are attached to Wi-Fi in the port. But in principle, all management is all monitoring is made using the edge machines. Well, or private cloud, you can say so, but basically they are edge devices that are collecting the data when a ship is offline, for example. Yes, in maritime, we can categorize IoT devices to different categories, depends on what they are doing. So for engine monitoring, for fuel management, for cargo monitoring, there is also these ballast bilge systems that have water level sensors and switches. A huge amount of IoT devices supporting navigations, including the GPS trackers or some weather sensors. There are other environmental sensors, like I mentioned already, air quality sensors that monitor CO2 and NOx or wall or some other parameters. Structural health, I guess many of you from the structural naval architecture, it would be very interesting to listen you about this, what kind of sensors nowadays is used for different ships. But what I have read that there are hull stress, strain gauges, and corrosion sensors, some of them like used only for the testing of the sea trial, for example, or some factory testing, sea trial testing, but some of them are permanently built into the ship. Yeah, I would be interested to know something about this case. Then crew monitoring, of course, the crew might have wearable tags, smart ID cards, Bluetooth badges, so those are all IoT stuff. In the port and dockside, IoT have what I showed you, RFID readers for tracking assets, for access of workers to the place. Then security systems also can have different types of surveillance and tracking systems. And autonomous systems, it's a separate nice story, which has LiDAR as a sensing system, technology, different kind of radars, cameras, and all kind of sensors also. Communications, satellites, IoT gateways we just mentioned. So those are all widely used devices in maritime. Challenges. Challenges to IoT from the devices comes from physical conditions to the connectivity and others. There are a lot of challenges that specifically for maritime. You can see here the effect on salted water on the this device. I forgot the name of the device. Was it measuring distance? I think it was this. Yeah, I think it was presence and distance measuring. I don't remember. I think so. So harsh environmental conditions, salt water, humidity, corrosions, and they degrade sensors and connectors to the sensors. And yeah, was it this ultrasonic sensor? I don't remember. So they are even they comply with the requirements, this IP67 for the being inside the water and so on, but still they are looking like that after some time. And limited connectivity is another challenge for devices. So device should tolerate the sudden or planned break in connectivity, because we know sometimes that if device is using, for example, satellite it's the most expensive and only from time to time, so you don't have all these connections yet. And cellular Wi-Fi, like harbor Wi-Fi, finished in 100 meters, and then cellular also not everywhere available in the ocean. So I mean, your implementation of your device should somehow be smart enough to buffer the data, to use some other channel, to transform the data to a very, very small package that can be sent to satellite or any other solution that you have, you can design. So power, many sensors operate on the battery, solar power. They can do that for months. This is especially important for those buoys and other autonomous maritime systems. And then they have to somehow be designed, those devices, so that either you send too much or you send more or less, or when. So it's a challenge. Motion vibration, of course, ship is vibrating, and some of them, they have to be for some of the, especially some smart computer system, it is a problem and big problem. I remember first it was almost unsolvable problem for some of the computers 30 years ago. Now they, of course, solve this, but still it needs some special design for the device. And increasingly targeted by cyber attacks. So they have to, traditionally, IoT didn't have too big protection against that, because I think from the beginning, nobody was thinking so much about that, about security of the device itself. Okay, what your coffee machine can send when you, how much coffee you drank or whatever. But finally, now, for last 4 years, security in IoT is the priority in the every year, priority number 1 on the main IoT trends for last at least 5 years. And I don't think it will go away very quickly. So security and privacy are the main trend and challenge now. And sometimes integration complexity, it's like you have so many systems in one ship that has to communicate and integrate with each other. That is obviously then they are provided by different vendors. And I know that the big cruise ship has at least 1,000 vendors when during shipbuilding. So each of them provide some systems which probably digitally managed and probably not very easy to communicate with each other or test together, let's say. So that's clear. We already mentioned several times main connectivity technologies. This is also Cesare question about what kind of connectivity, what kind of like costs. Yeah, they do cost differently, and some of them. So for some of them, you need to choose the whole technology in advance. For some, you can kind of, your device can support several. For example, some device can work with Wi-Fi and cellular, and some device, of course, LoRa sensors working only with LoRa connectivity. But they can also have nowadays maybe something, if it's enough smart device which has not only sensor but also some gateway inside. So this is not like black and white, but we can just go through them as they are the most common. So RFID and NFC, they are the same technology. So NFC, as you know, it's proximity, so it's very close. You need to put your mobile or your card very close to the reader, so it's less than 10 centimeters. Sometimes it's contact. And RFID could be up to 20 meters. I have never seen anything in 20 meters, but 10 I have seen. So your tag can be 10 meters from the reader. Low power or no power. So like passive, no batteries. It's good. Frequencies, it's important for other devices and for other things that there wouldn't be any interference or anything. I know that there are always questions, for example, around airfields, which kind of frequency are using for the radio communications. They don't like cellular at all, but some of they require clear declaration of the frequency you use. It used to be different frequencies for Europe and America. So for Europe was 800 megahertz and for America 900, but nowadays they are somehow combined in the wider range. So all devices could be in wider range. And readers send, like yesterday we had this example, readers send the radio waves, the antenna, big antenna, energize the passive tag of the passive antenna in the passive tag, and it gives energy as much as the passive tag can send the ID. So you get 92 bytes of information, not much, but it's enough to know who are you. So used in inventory, payment, success, authentication systems. Bluetooth, I have good example of Bluetooth. I will show that later. Zigbee, I have never used. I think the most advantage is that it has mesh as much as Bluetooth, but Bluetooth mesh is more expensive and more difficult to implement. Or maybe Zigbee has been designed as a mesh network that you can send through one to another node the data. It used widely in smart homes and hospitals, in lighting systems. It doesn't. It has low power. That's advantage, and the distance is 100 meters between each other. I think if you need to be node, it's 10 meters. If you are node, it could be 100 meters. I'm not absolutely sure. Wi-Fi, you all know the specification. So when you need big data, you use Wi-Fi to send. Cellular, the same, you all know you're using that. So the good thing, your Wi-Fi, it's like 100 meters, but cellular, it's national, regional range. LoRa is specific technology created for IoT. It's very cheap with very low power, very good, but very closed. And it needs close means that it has proprietary protocol. It needs several servers in between or it needs network server and some translation services between the LoRa and something else. But it's cheap. It needs infrastructure. It uses antennas. But those antennas are already everywhere, even in Italy. In even it's in Italy also because there are kind of mountains and other things. But we have seen that there are also public network for narrowband IoT, cellular, expensive. Low power devices could be, but price is high. Sigfox, I guess, is competitor of Zigbee. It's something. Well, it didn't mesh. It used star, so it needs central base station to be connected. Always to be connected to base station. I think it used somewhere in the home automation also. Satellite, yes, a lot of positive things, but the most expensive, low, and need power, of course, to send to satellite. And it's also small payload so far. No, I don't know. Maybe it can also have big, but how much it costs. How do you choose right connectivity? It depends what you want. So first of all, you need to figure out what do you need to connect, of course. You connect them. Do you want to connect inside the ship, or do you think about connectivity already outside to the cloud? Or so all of this has several options, and as a naval architect, you need to know your price, topology, device capability, and ship possibility sizes, and so on. So, but there are constraints, range and coverage. So which kind of options do you have? So if you want to use for ship tracking, you have to use satellite. Then data volume, how big data you need to send and how often you need to do that. You can have 5G for sending movies, cameras, and other things, but for the temperature from animal, you can use, for the tracking animal, you use LoRa, which is very little, very rare, and not often you do it. You need to also think about power. Power is low power protocols. You can have longer life of the batteries if you need. In RFID, you don't need any power even. So you kind of use very low power from this list if you have in the sea, in the ocean, those buoys. Latency, how critical information. So is it okay if you receive it like now, or if can it be delayed, and so on. Environment, different as we discussed, sensors are different and they have different connectivity to the device. So you need to figure out how to do that in harsh conditions, in salt water and in vibration. So, and how this vibration would affect your connectivity. Integration types, so how to integrate the difference of security and compliance. There are a lot of IoT devices that need certifications and compliance. This was our test 2 weeks ago. This is the drone, industrial drone. It has inside in the drone here, and this is the reader. It's similar to handheld reader for tags that I showed you yesterday, but it's static reader that we just fixed and made batteries here fixed. So it's like a prototype version. And it flies with the, you can see the size, it's me, and this is drone. So it flies and it reads this on, we put in several places those tags, and it reads tag from the at least 5 meters distance. It was reading the tags. Option for connectivity. Well, we used Wi-Fi, but this way we had to run with the mobile network point so that we would be close to the drone to at least 100 meters, that it wouldn't lose connectivity. So now it works with the from the mobile network. But I mean, yeah, should think the use case when you choose connectivity and many other things. But of course, several it will cost. Wi-Fi didn't cost anything, but this one will cost. Yeah, in maritime specific connectivity, to summarize, what is the maritime need for the connectivity? First of all, long range connectivities. That's obviously. So you need to have satellite communication. There are some systems already exist for global tracking and messaging. You can use hybrid systems. For example, on board you use Wi-Fi and Ethernet. And then you use cellular satellite when in the sea or Wi-Fi in the harbor also, if you can. Then we discussed environmental durability, salt resistance, waterproof, vibration-proof hardware. This is also limits because hardware itself limits connectivity because it's not only device, but there are also connectors that are affected by those salt resistance, waterproof, and other things. So you need to have safe for environment device and connectors. Power efficiency for remote devices, especially. Yeah, intermittent connectivity tolerance. We discussed that it's clear. Then if you are offline, your connectivity should tolerate it, not break, but buffer, use edge, do something to keep the data, not to lose any data, and then be able, as soon as you get any connectivity, to make decision, do I connect or is it too expensive, or do I connect only to that? What do I send? And security. After all this story with attacks, strong encryption, access control for critical navigation and engine system, especially for automation system. Yeah, if we see about the key components of IoT, maritime IoT connectivities, there are kind of 4 elements of the connectivity for maritime. So it's onboard networks, could be wired, Ethernet, could be Wi-Fi, a cellular link, satellite connectivity, and gateway and hub. So it's like communication bridge inside or then with others. Why it's important? It all takes space and it all needs configuration, and you know what you have. Those are the maritime connectivity types that you have. So you need to figure out how to use for which devices in which data type. What do you use and why? This is the this was this for satellite. I think so. Yes, this is this Iridium, I think, satellite gateway. So yeah, Iridium Certus satellite IoT developer kit. So you can program that. So it has also developer kit. But for different use cases, you have preferred connectivities. Like for ship engine monitoring, you use local Wi-Fi or internet. For vessel tracking of ocean, as we discussed, satellite. For port sensor network, you can use LoRa. It's used in Rotterdam, used or 5G if you need some pictures. For smart buoy, you use LoRa or NB IoT. For alert to the shore, you need to use cellular or buffer data during voyage or satellite. Airfeed NFC, we discussed a lot. I will skip this slide because you probably know everything I taught many times and gave all examples about it. How Airfeed works. This, by the way, this one is connected to the drone. Why to use in maritime Airfeed? Because of contactless identification, because it's fast, because all tags are very durable, and because it's low power and option for passive tags are very good option for the big shipyards, for example. For crew access also could be used in barges, and then for container handling, for some safety thing. So it's quite widely can be used, RFID, in the maritime for different stages. This is system what I'm developing. So the trucks are bringing some stuff to the harbor, to the shipyard. So there is somebody who is tagging them on the gates, and then you put them everywhere, and you have those antennas that I just showed you. And when you drive nearby, you know that they are there. It's kind of random, non-regular, irregular inventory. Because they are always reading. You don't need to particularly switch on to, for readers are always reading. So you can send drone if you don't find anything. Strengths of system, signal strengths help you to figure out the distance. You can, based on the strength of the radio signal, more or less triangulate and figure out how close it is and find it also. You can also track people, as we discussed yesterday, that they won't go behind the virtual gates. This is something that I would like to know more from you, is that about this, I think those devices, the amplifiers, they can connect several sensors that are, for example, used for the structure painting. So they are Wi-Fi and Ethernet powered. So if you know that you use these devices, they have to be either in Wi-Fi zone area, or you need to put the cables or plan how you put the Ethernet cables to them. Bluetooth is very good and stable technology. There is also a version of this Bluetooth low energy, BLE, widely used. And BLE is good because it's low power and very simple and short, but they are short range. And of course, BLE use less data and very low power usage. Then the distance usually from 10 to 100 meters. Never have seen 100. I have been participating developing the system with one company called SteerPass, Finnish company. They use these anchors for the tracing of the people, and it worked very nicely. So these anchors, they put inside building on the roof, on the ceiling, or it could be in the ship, in the ceilings. They put these anchors every couple of meters, and they are working as not couple, some 4 meters of distance or something. So they are just glued. They are small, about 3 centimeters, and they are just glued to the ceilings with the double-sided tape. And then if you allow to trace yourself, or if you want to trace some something, the mobile phone connects through the Bluetooth, and then because it knows to reach of the anchor, it nearby and to which like the distance, which is the better signal to which nearby it works. So it knows where are you. So there is a map, and on this map there are those anchors, and then you walk and it knows nearby each. It's quite good. It also makes triangulation, so it tried to read several of to connect to several of them and understand better where are you, and more you put them, better place. It's for indoor navigation when you don't have GPS. It's very good and cheap. There is another like Gupa when you have some wearables, which is more expensive because you are carrying the device sensors. Here, you don't carry anything because device is there and you are just scanning that with not scanning but connecting that with your mobile. So the elegant and simple solution. Huge troubles with the privacy, more than with technology. We were fighting for I don't know how many months, and I guess it's still unclear how to use that. Even you can have the zones when you are not allowed to trace, like, toilets on some other restrooms or something, but still huge amount of problems with the authorities about the privacy. Yeah, here it's a bit more information about the how this technology of this Bluetooth, so how it is, what protocols used. It used both request response model of communication. So when your, for example, one mobile device can request, and then it's also use request from the other device, some response. Then it can also publish the subscribe model when the sensor can send notification. So to their host, to their main device. Then it has, of course, this exclusive pairing, but it's in certain case when you, for example, logged with certain smartphone or something like that. So basically, in smart home, you have temperature sensors, and you use that in the door locks, and we use it everywhere. And then, like beacons, I used what I just showed you for the asset tracking for people, for worker safety. Yeah, there are some hardware and some firmware which can be used to build this kind of systems. Laura, this is probably last what we managed to discuss today, but this is the most important. So it has been created, introduced by some startup range. Then Semtech has bought it, and it becomes so strong in the IoT world that they have founded the Alliance. And now it's a standard, and there are a lot of networks. It's much cheaper because it sends only, it designed to send small amount of information. The base stations are cheap, easy to build, mount. And this alliance include such companies like Cisco, IBM, Orange. I mean, it's really already industry standards. So basically, it's the same thing. So it's IoT sensors and then LoRa device. Sensors can be anything, whatever sensors can sense. Then device has communication model that send data, connect to the LoRa base station. And then like that to the gateway to the internet, so that the data could go to the internet. There are three things to understand that the terms. Everybody call it LoRa, but basically LoRa is the physical layer, is actually the name of the radio. It's like a radio modulation technology. LoRaWAN is the network layer protocol, which is built on the top of this physical layer. And this is the LPWN. It's category of the network for the low bandwidth, long range communication. So The range distance is kilometers, and it's ideal for the sensor that are deployed across the farms or in other remote location. For the ships, not, but for the shipyard, yes. And if you have some devices that has LoRa communication, they not necessarily use when ship is on the ocean, but when they approach to the certain harbor, and harbor has network, then this device can communicate directly to the harbor LoRa network, which is widely used. There are two models how you can build private network of LoRa. You can build your own base stations and LoRa stations and build the network sensors network. But then there are already public network similar as cellular network what we have. Of course, not so developed yet. We don't have coverage everywhere. But here you can see there is this is a piece of Italy. In La Spezia there is nothing. But in Livorno, there is. And there are some here and there. Some countries, they are very well covered already. So next we wait for La Spezia. I don't know why it's not there. So why to use LoRa if you want to build IoT sensors network? First of all, they are ultra low power. They promise 5-10 years. 10 years, I don't believe. But somebody say that it will work. It's like, those lamps, what we are using. So they are also like all 10 years, after 2 years, they are gone. But maybe this is like on single battery, 10 years, good promise. Long range connects. What I know from the projects that I have been, that for the city area, it's not extremely long, and it has, because of the frequency, it has easy interfered with each other and with something else, because so it's not very well suitable for the city. At least maybe nowadays there are better. My knowledge about that is like from project which is 5 years ago. So they couldn't really make a good network in the crowded area of the city with the huge amount of buildings. They were planning to put them on balcons on the big houses, but it somehow didn't really work. But in the open area, it works very well. There is some security encryption, not in edge devices, but in principle, it's possible. And yeah, it's compact. It can support a lot of devices, and it works very well in star topology network. So you build a new station, and you have new devices there. You build a new, and so it's star. This is project I was working at, making architecture for that, how to use LoRa and IoT and Internet of Things. So how to include that to the Azure, to the cloud service, how to use Microsoft cloud services. Microsoft Azure doesn't support LoRa. No, LoRa supports only LoRa. So nowadays there are some big like Amazon, this AWS and others, they now have the connectors for LoRa, but in principle they were not supposed to have them. So you need to have in between here something. So if your ship has sensors that has LoRa, it's good. Because they will work for a long time, long batteries, they are cheap. You need to have only few stations somewhere. It's cheap to build a station for the receivers for the LoRa, but then to send the data to certain cloud to integrate, to integration work would be the most. So you need to have network server in between. You have to have maybe edge, not mandatory, but this is what I was doing, this part. However, after it's translated to the MQTT to normal, to the format of, and LoRa has MQTT also, it's just in different format. So you get the data, it's also MQTT protocol, but it has different format. So you need to format that to, let's say, Azure or some other hub format that understand and send it. And as I said, there are some big middleware platforms already have connectors for LoRa to connect. So it's very, very well and good growing technology. Port of Rotterdam has it. It used for several pilots. Well, the architecture is simple, like here. So they use that for several pilot projects. Oh, I don't know what's nowadays there. This is what they advertised, that it was like about 15 kilometers, almost far, and so on. I don't know. But they have systems of the receivers, gateways, and then they use it for different in application server and cloud platform to analyze the data. So I guess they use it for hydrometeor networks, for valve, open, close. It's for this fuel storage as well. Is it like open or closed state for safety? And yeah. I think also maybe for access. I don't know what's after this pilot happened, but it was widely advertised, this solution. Yeah, and we have for today, I think we don't have any more time for anything. Yes, and we are over time. I mean, I have only 2 slides that there are cellular collection available with the real world. Maybe we can go through them briefly tomorrow. I think yes, I think we finished for today. And yes, thank you very much. Any questions you can ask me offline also. And I will now sail until late evening, but tomorrow I'm available to read and any questions to answer. And yeah, any questions or